All right, so now we're moving on to the next Gauss-Markov assumption. So second one is the correlation between the error term and the explanatory variable has to be 0. So we're going to do this one. You're going to use the formula back in chapter 8. So we're going to do a t-test, but for correlation. So the null hypothesis would be that that it is 0. So the null hypothesis is that the assumption holds. The alternative hypothesis is that it violates the assumption, the second assumption, so that there is a correlation. So in order to check the correlation of the error term and log start to flow, we're going to use NumPy's. You can do this a few different ways. Pandas has a correlation. There's some ways to calculate here, but we'll just do a correlation coefficient. So return to Pearson correlation coefficient. We'll give it next, give it a y. Let's calculate the correlation coefficient between the regression residuals and our log start to flow. This is going to give us an array, and as you can see, it is pretty close to 0. If we plot it out, you'll see it as well. Let's do a scatter where the x is going to be equal to the x values, y will be equal to our regression residuals. You can see that it doesn't seem, may not necessarily seem that they are correlated. Doesn't seem quite like correlation. Seems like there may be autocorrelation with the residuals, but maybe not so much the x value or the log start to flow. So right now we're just focusing on the second assumption. So we want to know, is this equal to 0, or is it statistically significant given a 5% hypothesis or a 5% significance level? So to get our correlation coefficient, be that one up in the corner. So we got that. This is our R. N would of course be the number of observations for the regression, and our t-stat. Again, this formula is back in chapter 8, and the t-statistic for a correlation coefficient, we would do the correlation coefficient multiplied by the square root of n minus 2, because there's 2 degrees of freedom, divided by the square root of 1 minus r squared. Let's output our t-stat, and it's a pretty small number. So let's actually calculate what that would be. So here, this is using the CDFs. This is a cumulative density function. So we're saying, what is the probability that we get this t-statistic given that the null hypothesis is true? And there's 2 degrees, I'm sorry, the degrees of freedom would be n minus 2. So we calculate this, and we get 50%. So it's fairly likely that you would have this number given that the null hypothesis is true. So we failed to reject the null hypothesis. So it would appear that this assumption holds. So in the next video, we'll do the Bruce-Pagan test for heteroscedasticity.